Good morning. Today we're going to talk a little bit about the THC. We're also going to talk about consumables, and we're going to talk about how the two interact on our system. Before we get started, I really want to start diving into consumables here. We have very strict rules when it comes to consumables, and so does your plasma cutter. So we're going to take that down. And then once we go through the consumables, we'll talk a little bit about the THC, and we'll talk about the voltage that's present on this particular manual here. For the purposes of this discussion, we're going to be utilizing the Hypertherm 45 XP manual to showcase a lot of what we're doing here. Let's get started. So what I have here is the cuts and marking chart as listed by the Hypertherm 45 XP in their manual. Now, I may have a generation back on the manual here, but we will go ahead because the consumables are the same. And now, if you're using the Hypertherm 65 and 85, and they will also be using a very similar consumable set, at least when the 65 and 85 are using the 45 amp setting. That's right, you would dial back the 65 and the 85 back to 45 amps and use 45 amp consumables. Now it's extremely important that you note that this consumable right here, I'm going to go ahead and just grab a marker there. Okay, perfect. This consumable right here, wow, I can't draw. There we go. This consumable right here is specifically for 45 amps. That is, you cannot use 65 amps through this consumable, through this particular part number right here. You cannot use it for 65 amps or 85 amps. This is rated for 45 amps, and we're going to keep that there. This is the electrode. This will remain static for all of the operations. I don't know of any specialty electrodes on the 65, 85, and the 45 XP. That I don't know of any specialty electrodes for that outside of their higher quality variation. But again, they're all using the same electrode here. So we're going to go ahead and erase all that. So one major factor when it comes to putting together your torch and your components, outside of having these parts, is to make sure that your shield is paired with your nozzle. Again, you'll see later on, this electrode really doesn't change, so we're not going to touch that much at all. Just make sure you have enough of them. But we are going to make sure that this electrode and this nozzle and this shield go together. This retaining cap, they also have an ohmic switch that has, this weird little tab with a piece that goes around it. They have those things. You can use them if you like. The difference is negligible in this case. The one thing we do want to make sure that we have is this shield here has to be paired with this nozzle. And this is just a standard shielded consumable. So make sure you have the shield and the nozzle and that they pair up. You cannot use this with any other shield. And I will show you the other shields here right now. Now, for instance, this is the fine cut low speed consumable kit here. One thing I'm going to recommend for our system here is make sure that you're using the 220948. This one right here. This guy. The reason I want you to use this guy is because we touch down onto the material and lift off in order to find the actual surface of the material. Now, in this particular ring, this little half circle is going to be protruding out of this shield here, or deflector, and making contact with the actual nozzle hole. So if you have particulates or other molten bits of metal on your material surface, it'll then adhere to the surface of this nozzle, and that'll impede your cut, and you'll see a greater likelihood of actually losing arc or not initiating an arc just because you have some sort of piece of material blocking that little hole there. But we use this 22930 nozzle with this 220948 shield. We do not use the 220941, I believe is the part number. Don't quote me. We can probably scroll back up and take a look at that here. But we want to make sure that this nozzle, these nozzles, are only used with this shield. If you try interchanging or intermixing those consumables, it will not fire. It absolutely, or if it fires, and I should put this as a caveat here, if it does fire, you're not going to get a clean or cuttable arc from your nozzle. It'll end up actually just gouging the surface. Now with thinner materials, it may blow its way through, but again, not accurately or correctly, because these nozzles are designed to function with these shields. So all of these go together. Now, I say all of this because the way that these nozzles interact, and if we look at the specs down below, we will see that the nozzles correlate to a specific voltage on a specific material at a specific speed. And let me go ahead and break that down. I will just say one last thing here. With this low speed, we also have this option here, which is the swirl ring. You want to make sure you have the appropriate swirl ring, because again, that does impact the plasma arc. And the plasma arc is what gives us our voltage, and that voltage is what helps us determine the height. Alright, so on our systems here, we're going to transition over to THC. And on our systems, the torch will come down and sense the material. We have two different ways of sensing the initial height, and they're two separate systems, but a lot of people like to group them all together as THC, and technically you're not wrong. This is all part of torch height control, but in our systems they function separately, so to troubleshoot them, you would troubleshoot them separately. Here we have the torch finding its initial position. It'll come down, touch the plate, and lift off in order to get to the appropriate pierce height as defined by the manual. And then it will fire, cut down into the material, and then drop until it reaches cut height for moving it. At this point, the THC that reads voltage senses the height of the torch. It actually takes time to read the voltage from this system. And let's explain what that means with a different image. So we're going to do a little bit of terrible hand drawing here. We'll get to that. So from here we have a torch at a given height off the material. We have a torch at another height off the material. And we have a torch at a lower height off the material. And we're going to notice here, I love this image because it actually relays so much information here. When the torch is too high, you end up getting a bevel like this. When the torch is too low, you'll get a bevel inward like this. So a bevel out and a bevel inward, depending on how you want to reference this bevel, as opposed to here, where you actually get an appropriate cut and perpendicular kerf on this particular cut when it's at the appropriate height. Now, I won't go into, let's just say, the electrical background on this, because sometimes that can be a little bit intimidating. The big thing that you need to know is if the voltage is higher, it's going to be further away from the material. So let's just say if we're using fine cuts on 16 gauge, moving at 249 inches a minute, again, I'm pulling these from the Hypertherm manual, this is going to be 78 volts right here. Perfect. All right, so if this is 78 volts, that means that when I have the machine set to 78 volts, even this material, if this material were to start to warp upwards, it's going to keep this gap, because for the plasma cutter, this gap is equal to 78 volts. If we had the THC set to, let's see a common number here, 120 over here. So if we had this set to 120 volts, we'll notice that the gap is higher because, one, we're using fine cut consumables. So fine cut consumables with the 45XP cutting this material, so 16 gauge, let's see, 16 gauge, 249, wow, 49 IPM, there we go. 249 inches a minute, 16 gauge, fine cut. We have 78 volts, making this height, meaning that if it was at 120, it's going to raise the torch upwards. It's going to raise it the torch until it reaches 120. The THC is going to take whatever point that it's at and keep raising the torch until it reaches 120 volts. Or let's say you had it set to 45 volts. So after the torch comes down, touches a material, and fires, it's going to start reading voltage. When it's set to 78, it's going to move the torch to the height that gets the system to read out 78 volts. When we turn on the torch and we have it set to 120, and it's this setup here with the fine cuts, we're going to see that the torch is going to try to raise up to 120 volts because we set it to 120 volts, and it's going to keep climbing until it reaches that number and then hold that number. Similarly, 45 volts is going to keep climbing downward, more than likely into the material, until it hits 45 volts. So we see here that at each voltage we're going to see differences in cut height. So let's go ahead and change the parameters here. Let's say we are going with we're going to go ahead and go with standard consumables for the 45 XP. We're going to just stick with that 16 gauge, primarily because the cut speed is again going to be 249 inches a minute. Now we cut 249 inches a minute with the fine cuts as well, but this is going to be with a standard cut consumable, so that that conical shield and that conical nozzle is what we're going to be using for this. Now for that, the actual voltage here is going to be, I believe, 138. We can check the manual here in a second, and that's going to be an ideal height. Now, what if we had set it to 120? Which one of these are we likely going to see if we set our THC voltage to 120? Well, when the torch touches down, lifts off, starts its cut, if we see 120, 120 is less than the ideal voltage listed here. 120 is less than 138. So likelihood is we're actually going to see the torch try to push down into the material while it's cutting. So that's at 120 volts. This is where we're going to end up, as opposed to here. It would have to be something like this would have to be, so that's 120. This one would have to be something like 200 volts instead, and that would cause the torch to raise up off the material. And again, this is with standard cut consumable. Despite the fact that it's the same material and same speed, the height that it's supposed to be at, which for the hypertherm is 0.06 inches here. So this ideal height of 0.06 inches, when using standard consumables, the torch is going to tell us that this height is equal to 138. With fine cut, this height is equal to 78 volts. So you're going to need to make sure that when you do use a different consumable, a different voltage is used, because they're going to require different voltages. Let's take a look at the manual and let's show you the differences. Alright, so here we are looking at the fine cut shielded consumables page here for mild steel. It's actually listed at the top here. Let's go ahead and zoom in just a little bit here. So here we have the fine cut air for the shielded and unshielded consumables. Now I'm going to go ahead and go down to the English measurements because that's what we're using here. And what we're going to see here is at 16 gauge. Now, another thing to note is it only goes up to 10 gauge here. 10 gauge is the maximum thickness that fine cut can actually cut on with the 45 XP or with any of the fine cut systems. 10 gauge is the max on mild steel. We want to pay attention to a couple of small things here. Oh, here we go. All right, so 16 gauge, we're keeping a cut height of 0.06. We're using 45 amps here. And 16 gauge 0.6 away at 250. So I was off by 1 IPM here. So it's 16 gauge all the way across. We have a cut speed of 250 inches a minute, and we had 78 volts. And at 250 on 16 gauge, we get an ideal. First off, this is what we call the best cut quality settings. So this is what Hypertherm recommends as an ideal cut quality based off of the cut speed here. So we have 250 inches a minute, 78 volts. Now we'll notice that despite the fact that we are cutting at a different speed, the voltage is exactly the same on 14 gauge mild steel, but we've slowed down. We're cutting a thicker material slower and using the same voltage. Again, we see that again, 12 gauge, 120 inches a minute, 78 volts. We're keeping the same voltage here, which is what's great about these fine cuts and these best cut quality settings, is as we vary speed, if we vary speed, but also vary thickness, some of the voltages remain very similar. However, if we were to change the speed but not change the thickness of material, we have to change the voltage because the voltage reading is going to be different. If any one of these change, if we change material thickness, we should ideally change speed, but if we don't change material thickness and change speed, the voltage has to change. It's just a rule with all of this. All right, well, let's go ahead and actually take a look at the normal consumables here. All right, so here we are dealing with the mild steel 45 amp tool settings. We're using this tool set here. That's awesome, the 220941. This is this little conical nozzle here. We have the conical shield here. We have all of our consumables. If you have this appropriate consumable set in, we're going to go ahead and go to the settings here. And let's get back into drawing with terrible accuracy with a mouse, because that's what we do. All right, here we go. We have 16 gauge here. And again, we're working with 16 gauge here. Same torch to work distance. That's the great thing about the Hypertherm, is they've dialed this all in to have that same torch to work distance. And what we see here, oh, I was wrong. It was 128, not 138. There we go. All right, 249 inches and 128 volts. 128 volts at 249 inches a minute, 16 gauge, using the mild steel shielded consumables. We notice that while we're keeping a very similar speed, the voltage is extremely different, and despite the fact that it's on the same material, we see that change. So it's got to be based off of that consumable. So 128 is going to be your voltage on that consumable. And we can see our voltage is going to continue to increase based off of our different speeds here and thicknesses of material. And these are all calculated to give us the best cut quality. So at a half an inch of material, we are cutting at 18 inches a minute, and our voltage is significantly higher. And again, if we were to increase the speed here, we'd also, let's say we were trying to cut half inch at 249 inches. Well, first off, we were not going to be able to cut through half inch at 249 inches a minute with the 45 XP. Just not possible. So we're just going to end up marking the surface, which will continue to throw off our THC. So again, this is all to point out that as we're working with our THC, we're going to have to set our voltage to our consumable and our speed and our thickness. All of these things must come into play, and if you don't use all three, you're going to end up getting some poor cut quality across the table here. So keep that in mind. And what I love about this particular sheet is we can also see what they call production settings. So if we were to increase the speed, we see that the voltage decreases. So from 128 to 125. It's strange because actually I've never seen this where 10 gauge is the exact same regardless of the speed here. Very uncommon as far as I've seen. But you'll notice here that across the board as we go down the sheet, if we increase the speed, we have to decrease the voltage. We have to, and it's I really don't want to have to go into the mathematics here or the science end of it, because as a user, that won't be as necessary. One of the critical things here to understand is you increase the speed, you decrease the voltage. However, ideally, you're always going to want to use the best cut quality settings on your system Now, that isn't to say that this is going to be, the perfection. This isn't always going to be the case. Things that impact cut quality can also be things like your consumable wearing out over time. We're talking about our any damage to any of the nozzles, the shield, all of that can impact what our voltage is going to come out to, the quality of the air coming in. So you have water in your line, dust in your line, oil in your line. You have all these other particulates. This can also impact your voltage that's being put out by the plasma cutter. So you need to keep those in mind. You will have to do some micro adjustments. We knew a fella back in the day that used to actually have to adjust his THC based off of just different weather conditions. It was a hot and sunny day, and he was operating the THC at 1 voltage, and it was a frigid, freezing night, and he had a different THC voltage. There were some small changes he had to make because the external factors impact some of the voltage. Now, if you're using proper filtration and you're using a lot of these standard pieces here, a lot of affecting what's coming into your plasma cutter, a lot of what's as long as you're getting that clean air coming in there, a lot of those problems will begin to disappear. So keep that in mind here. Best cut speeds here based off of the Hypertherm manual. If you're using another plasma cutter that doesn't give you that information, you are going to have to experiment a little bit, but that is sort of the nature of the beast. When it comes to dealing with the Hypertherm, though, they do give this all to you. So keep that in mind, and happy cutting.